3, 4, 5.
Greetings. This is the dynamic duo of a team of Jorge Santiago, faculty in the University of Pennsylvania, and Jerry Light, also a faculty in the same institution, and our relation with the group in Africa. Actually, this relates a very tight relation that was developed through half a decade between us, some faculty, and about a dozen students from the University of Pennsylvania, and the girls in a particularly excellent high school for girls near the city of Kigali, in the village of Gashora in Rwanda. Next slide, please. These high school facilities, it's located about 1 hour drive from the city of Kigali, and which is the capital of Rwanda, of course, and close to Lake Rumira. Lake Rumira, it's a substantial lake, about several square kilometers in capacity, and this is the place where all the potable and service water for a village of many thousands is obtained. Unfortunately, and it must be due to the lack of sanitary facilities, the lake is a vector for schistosomiasis, for bilharzia. And bilharzia, it's a very, very common problem in that region. The facilities for filtration of the water and cleansing of the water are fundamentally very heavily taxed during the rainy season, during the wet season. And our effort was implemented to see how we can, our combined Gashora Girls High School and us and ours, trying to help. Next slide, please. So the clinic of this village, it was a substantial clinic that it was designed for taking care of 500 patients daily. And it was the only medical facility in the village. As I mentioned before, a village of several thousands. It takes all the water from this lake. But the problem is that the lake and the clinic lie reasonably far away, maybe 1.5 kilometers to 1.6 kilometers, one from the other. And a trench has to be dug between the village in order to implement our design. And our design include the pumping facilities right there at the lake shore, and PVC tubing installed, plastic tubing dug up and buried for a distance of about 1.5 kilometers all the way to the storage facility, and then to the cleansing facilities in by the clinic. In this slide, you can see the digging effort. You can see in the left-hand side, you can see very close to the lake shore. You see behind those two guys in the photo, you see the lake shore. This is at the end of the dry season. And in the right-hand side, you see when we are moving very close to the clinic facilities, but nevertheless, it is a cavity of about 1 meter in the spacing and about 1 meter deep. And it accommodates several rolls of half a kilometer each of black stable PVC plastic. The students and volunteers from the village helps GIGAS and us in putting all the digging and placing all the tubing and attaching pieces of tubing to the storage tanks and to the pump. Next slide, please. So we utilize, as you see, 4 rolls of 200 meters tubing, a black PVC storage tank of 5 cubic meters. That's for the storage of the water. That's for the storage of the raw water. The raw water has to be filtered, and then it has to be treated in order to remove the problematic the problems that were carried by the water. The equipment includes a piston pump. It is the best pump that we have seen. We have some experience. We have done some previous work near the village and utilized a similar pump, Dankoff pump. And for energy storage, we used lead acid batteries that we obtained in nearby facilities. And for the final treatment of the water, where we kill all the biopsia in the water, we used ultraviolet light emitting diodes, and they were all purchased in the United States and carried by us. The same with the lead acid batteries. I'm sorry, the same with the Dankoff pump, the lead acid batteries we purchased on site. We tried to do as much as we could as our purchase of equipment in the city of Kigali for convenience, because it was reasonably nearby and we don't have to do all the traveling with so much equipment, but also for the good relations with the people in Rwanda and in Kigali in particular. Next slide, please. So as you can see, it was really a wonderful opportunity for us and for the students from the Gashora Girls High for Science and Technology to really do and excel in everything that we have practiced and learned in the regular schooling. We definitely dealt with the energy fundamentally. All our energy was from photovoltaic sources. The panels were purchased in South Africa through a local in Kigali. We dealt with putting the system together with the electronics. We dealt with the power generation, the power conditioning, the water pumping, the avoiding losses in our pumping systems by minimizing the number of elbows and trying to keep the gradient as constant as possible. We discussed among ourselves all kind of possible designs for the last part that powered the ultraviolet light emitting diodes. We discussed the biology related to it. We discussed as much as we can, as we could, in terms of what we assessed was material that our students have done at Penn and the material that the girls have done in the Gashora school. We did measurements with equipment that we have at hand. So we tried to do as much of a characterization as we could. And I think that perhaps the most important part in terms of our approach, it was allowing the two cultures to jointly design and put together an exercise in engineering and technology. I think it was wonderful. I think it was very well exercised, very well put together, and everybody really enjoyed it from the perspective of enjoying each other's company, but from the perspective of learning different ways of doing business because of different constraints from each one of the two groups that we uh, shared this adventure together. Next slide, please. This is an schematic of the project in general. You can see in the upper part, in the left-hand side, the lake level and how we put a photovoltaic tower. Actually, it looks so much like the true tower that we placed in there, and how we connected it, how we connected electrically from the photovoltaic panel. We went to, we did not use this time charge controller. We used a linear current booster. All we needed was for, we have enough generating during the day to really handle it very nicely. And it shows the PVC tubing. It shows the two tanks that we used. One tank actually, it was matched to the power of the pump, so we can outload our water from that tank to the tank closer to the clinic, where we can pass it then through the filtering and germicidal UV light in the very near the facility, very near the clinic. Next slide, please. So these are pretty much the outcomes. In the first year, so we were 2 consecutive years. During the first year, the output was fairly clean, mostly during the dry month. During the rainy season, we really had some difficulties. During the rainy season, the lake level raised above the platform we have prepared, a cement platform where we put the Dankoff pump, where we put our piston pump. So the piston pump was underwater, but it was not underwater by a little bit. All the information that we got was apparently a very rough approximation, and we had some difficulties in there. But in the second year, we repositioned the pump. We replaced some parts of the pump because, of course, the pump was underwater for a long time. We replaced all the electrical breakers and fuses, and we had all the people from the Gashora girls high, and people from the clinical facilities, we sort of discuss with them what would be the sequence of steps to follow in case that there is some difficulties. Next slide, please. Thank you.